we're going to illustrate a scenario of page replacement algorithm in virtual memory management. First, we need to know what is virtual memory. Virtual memory is the extension of primary storage or RAM by using the secondary storage or HDD. There are two replacement algorithms will be covered, which is first in first out and least recently used. Now, imagine that you are in a library and you as a student wants to get some books to read. You will go to the shelves and choose or pick the book you want to read, which is similar to data retrieval process. Once you had finished reading, the book will be stored back to the shelf. This scenario is similar to data storage process. From this scenario just now, shelf is equivalent to the primary storage or RAM, while book is equivalent to data. Let's look into a situation when the shelves are fully occupied and new incoming books need to be stored. This is where we apply FIFO, in which the old books on the shelves will be stored in the basement storage to give space for new books. Another situation is when the data requested is not available on the primary storage. This means the book requested by many students is not available on the shelves and it needs to be fetched from the basement. LRU could help by storing the least recently used book in the basement to give way for the mostly requested book to be on the shelves.
Allah barakatuh and greetings everyone. This is a simulation to show how does virtual memory works in storing data. Here, this is the website that we will use to show the process. First and foremost, the virtual memory is a feature of an operating system that enables a computer to be able to compensate for shortage of physical memory. The virtual memory system allows a computer to run larger applications or multiple applications concurrently by temporarily moving some data out of RAM and onto a hard disk. This way, virtual memory provides the computer with a larger pool of memory to work with, even if it's not all located in the RAM. There are many algorithms that can be used. Here is the first in, first out, least recently used, and optimal. I will present FIFO or first in, first out. Here we have the reference string. This one is a sequence of memory reference made by a computer program, typically during its execution. The memory reference can be to either data or instructions. In the case of data reference, the reference string can be used to analyze the behavior of various memory management techniques, such as caching, paging, and virtual memory. Here we have the frames of physical memory. Here we use three. This one is a fixed sized block of physical memory. It's used to store the data for a page of visual memory. Here this is our input here, and the output will be shown at this side. Okay, when we press the submit, we found that here we have three frames, 1, 2, 3. Okay, and here this is the reference, and this is the time. Okay, the first one come here, then 1, 2, then 1, 2, 3. The next action, the 4 will come and search for the first one already entered in, and it was a 1, so we will replace the 1 with 4. Okay, then the next one is 2, the number 2, but we already have 2 in the we already have 2 here, so we don't need to replace it. Okay, so the next one here is 1. The first one entered in was 2, so the replaced one will be 2, and the new items will be 1, 4, 3, and so on. Here we have 16 page fault. If we increase the frames of physical memory here, let's say 4, we will find that the page fault already decrease. If we make it 4, if we make it 5, okay, we will find it it has become 10. So as the frames increase, the page fault decrease. And thank you.
Hello everyone, my name is Aminu Ibrahim and I'll be explaining the LRU. that is the least recently used page replacement algorithm. We can see the number of frames, the reference string, and the column limits. So we submit to run the simulation. From this, we can get the solution visualization. These are the reference strings and these are the frames. So we can see here that since the frames are empty, that is, we can input one here. Then we move to the next reference string. Since 2 is not available in any of these frames, we input 2 and the 1 goes below the 2. It goes down a frame, that is. Then since 3 is not available in any of these frames, we input 3 and these 2 frames go down a frame. And then we go to the next one, that is 4. Since 4 is not available in any of these frames, we look for the least recently used, that is between these three values, which is the least recently used, and we can see that that is 1 because 2 and 3 come after it. So 3 and 2 go down a frame and 4 is placed here to replace the 1. Then we go to the next, then we can see 2. Because 2 is used in this frame, we can say that it is a page hit, and these are regarded to as page faults. Since it's a page hit, 4 and 3 will go down a frame and 2 goes to the top. We move to the next frame and we move to the next reference, sorry, and we see that 1 is the reference string. From here we can say that 1 is not used in any of these frames. So we replace 1 with the least recently used. And from these values 2, 4 and 3 we can see 3 is the least recently used. So 2 and 4 go down the frame, 1 comes here. Then we move to the next, that is 5. 5 is not used in any of these frames, so we look for the least recently used, which is 4. So 5 replaces 4 and 1 and 2 go down the frame. The same iteration for this and this, which is, that is, it's a page fault, it's a page fault, it's a page fault, page fault, page fault. Then we come here for reference string 2. Since we can see that 2 is used in this frame, 2 goes to the top, 1 goes down the frame, and 6 remains, hence a page hit. This is a page, then the next one, 3. 3 is not used in any of these frames, hence we look for the least recently used, that is the least recently used from this, which is 6. So 6 is replaced with 3, 2 and 1 go down the frame. That is repeated and that is repeated. Then we go here, 3. Since 3 is used here, 3 comes to the top, 6 and 7 go down the frame. A page hit. The next one, 2 is not used, so 2 replaces the least recently used 7, a page fault, and that is how it continues to the end. From the table and from the results, we can see that there are 20 total references. There are 7 total distinct references. There are 5 hits, 1, 2, 3, 4, 5, and the rest are faults. And the hit rate can be calculated along with the fault rate. From our calculation, we see the hit rate is 5 out of 20 and the fault rate is 15 out of 20. The answer can also be expressed in percentages. Thank you.